Emma, what are you doing in here?
I'm testing the coefficient of static friction. I have two objects here. I have a really heavy laptop and I have a lighter pencil case here. And so we're going to measure the height of the table. All right, we'll do this really quickly. So each ruler we have here is 15 centimeters. So we have 1, 2, 3, 4 times 15, which is 60, plus, we're going to say 10 centimeters. So that gives us 70 centimeters high. All right, the next important measurement we need to take is the length of this table. So once again, we have our 15 centimeter rulers. So we have 1, 2, 3, 4, 5. That gives us 75 plus 5 centimeters. So our table is 80 centimeters long. Let's keep track of these and write them all down. So we had our height was equal to 0.7 meters, and our length is equal to 0.8 meters.
Okay, now that we know the height and the length of the table, we should probably figure out the masses of these. So we measured this earlier, and this was 2.96 pounds, and the pencil case here was 1 pound.
So I think the laptop is going to have a greater coefficient of static friction because it's so much heavier than the pencil case. What do you think, Caitlin?
I think that they will have the same coefficient of static friction because it shouldn't depend on mass. Let's go take a look.
Good.
Okay, so first we're going to look at the laptop, and I'm just going to tilt it until it starts to fall.
Good.
Okay, so when the laptop just began to slip, we measured the height from the ground, and we found that to be 0.75 meters. And then to get the actual angle of inclination, we only need the length of the ground minus the length of the table, which was 0.7. So we found that to be 0.05 meters. So now here we have a right angle triangle, and we know that the hypotenuse is the length of the table that inclined up, and that's 0.8, and then the height that we measured was 0.05 meters. So now we can take sine theta equals opposite over hypotenuse, which is 0.05 over 0.8, and then we have theta is equal to 3.583 degrees. Okay, so now let's look at a free body diagram of the object. Okay, so I just went ahead and drew a free body diagram. So here's the object right there. So it have a normal force perpendicular to the object, and then it has static friction going opposite to intended direction, gravity down, and then using the angle we just found, we split it up into components. So this is mg cos theta, and this is mg sine theta. So here we're gonna just split it into components. So some of the forces in the x would be mg sine theta minus friction. And since there's no acceleration, that means F net is equal to mass times acceleration, which would equal to 0. So we can rearrange that and go Fs equals mg sine theta. Okay, now let's look at the forces in the y direction. So here we have the normal force minus mg cos theta. And same thing, this will equal 0. So now we have normal force equals mg cos theta. So another piece of information we know is that the force of static friction is equal to the coefficient of static friction times the normal force. So this we can write as that equals mg sine theta. And because we're trying to find the coefficient of static friction, this equals mg sine theta over the normal force. But we also know the normal force is equal to mass times gravity times cosine of theta. So divided by mg cos theta. So these two cancel, and we're just left with, we can turn this into tan theta. So the coefficient of static friction is just equal to tan theta. And we already solved for that, so tan of 30.583 equals equals 0.0626. And that's our coefficient of static friction.
Oh, so see, when we're calculating the coefficient of static friction, we don't actually need the mass because the mass cancels out. So it shouldn't make a difference between the pencil case and the laptop. So I was probably wrong. Let's just test it to make sure. All right, we're just gonna do a little test and measure the angle to make sure that our coefficient of static friction is the same. All right, lift, 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 lift. All right, let's measure the height. We have 1, 2, 3, 4, 5. 5, so that's 75 centimeters.
So that was the exact same as the laptop. Therefore, the coefficient of static friction would be the same.